Hey guys, this is Ed from Mission Impossible. Welcome back to my 8-bit Atari assembly language tutorial series. We are making a roguelike. This is episode 24 where we're going to be adding player actions. Let's get into it. So last time we went through and we fixed the colors and we ended up turning off collision detection. So we're going to have to turn that back on today. But one of the things we're going to be doing today is making it so that when I hit a button, I can open and close the doors. Eventually, we'll be able to do things like attacking monsters, opening chests, things like that. But first of all, what we want to do is we want to clean up this code and make it a lot easier to deal with when dealing with both actions and movement. Okay, so I've created a new branch, and first thing we're going to want to do is we're going to want to set up some new labels, some new memory locations, etc. So let's get that going. So in the labels, we're going to be using a few new ones. I'm just going to put them at the end here, which is fine. So we're going to use stick up. It's going to match what we're doing on the joystick. Okay, so I'm actually just going to copy and paste these. So we have up, down, left, and right, and this corresponds to the directions on the joystick. If you remember, this is a bitmap, so that if you're pressing up and left, that means the last bit will be firing and the second bit will be firing. So that way it would be 0, 1, 0, 1 would be up or left. We don't deal with diagonals in this game, at least not yet. And so what we're going to want to do is basically convert this into a simple enumeration, basically of saying up, down, left, and right, and so that we can deal with that a little easier. We also are going to be dealing with the button. So the button is kind of interesting in that when you press the button, it actually has a 0, and when you let off on the button, it's a 1. It's kind of reverse of what I would think of that it would be logical, but whatever. It is what it is. And let's see. I think that's it for labels. No, we have a few more. We have north, south, east, and west. I'll clean up this code later, but the idea here is that we're going to be converting this so that basically this is the enumeration for the different directions. And so the first thing we're going to do is we're going to convert all of the stick input into north, south, east, and west using this. 0 in this case would be no movement. A couple other things we need to do is we're going to need to set up some new memory locations. So let's go ahead and do that. Okay. So we have a couple of memory locations that are going to be for pointers. So we want to create a couple of new pointers called player pointer and direction pointer. I've just set them at DE and E0. They're probably going to move around, and I actually have a new way of wanting to lay these things out, but to keep it simple, I'm just going to put them here. We also have, let's see, we have a couple of other variables that we're using. Which are these? So we have stick dir, stick button, and stick action. And so these are going to be for the direction. The stick dir is going to have this north, south, east, west in it. The button will basically have if it's 1 or 0. And then the stick action is actually going to be used so that we can debounce the input. We don't want it to be able to hold down a button and be able to open up a door and close a door and open it. And basically, if you hold down in a direction, it'll just flash back and forth. We don't want that. We want it so that when the player holds down the button, does an action, they have to let off and then push it again. So we have some debouncing logic that we'll be putting in as well. And that's what this stick action variable is using. Okay, and let's see, a couple macros that we're going to be using today. They're pretty simple, actually. We have LDI, which is a load by indirect. This is a dereferencing function, basically, so that when you pass in an address, it'll return whatever that address is pointing to. Okay, and in our case, what we're going to be doing is we're going to say there's a location in the map that the player is located or that they're looking at, and we want to return the tile, like the number of the tile that's in that map. And we also want to be able to store that. And so these are little tiny little macros, but they'll make the code a lot cleaner. Then we have another one that is for clearing a location. So we have MVA 0 and then an address. This is going to basically say we're going to clear it. We're just going to set it to 0. To me, this looks better when you use like a macro to do this than this here. The reason why this is better for me is the intent is clear. It's like, okay, we're moving 0 into here. It's like, oh, okay, but we're clearing it. Okay, that's all we're doing. It's minor, but whatever. Okay, so next, what we're going to do is we're going to be creating a new file, and we're going to call it input.asm. And so I'm going to copy and paste. I normally don't do this, but it's better than you hearing me click, 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 click constantly. So we're going to, let's do this. What I'm going to do is I'm going to copy and paste chunks, okay? So we're going to be creating a new procedure for read joystick. And what I'm wanting to try to do here is establish that we're using some temp variables. We have temp1 here, which I believe in the past we've used just temp, and that's fine. But I'm gonna set up basically a new one for temp1. I don't know what's all available. Again, in the future, I want to have a video where we're going to do a whole memory map modification, but. So for right now, I'm just going to put it at the end, just so that we're good here. So we're going to say E0, E1, that's going to be for dir pointer. So I'm going to say E2, okay? And then I'm also going to do the same thing for temp2. We're going to put it at E3. And in here, what we're going to do here is we're going to say, so that we don't have to use temp1 and temp2 everywhere, what I want to do is basically have these be able to be reusable. We've done this in the past, but I'm trying to make it a little bit more formalized in that we're going to say at the beginning of our procedures that we're assigning this variable cur button to temp1. And so, so I want to do this for more procedures. And as we go through and clean up a lot of old code, we're probably wanting to do something similar to this. Okay. So the first thing we're doing after we assign this is we're going to be copying the value from the button, which is string 0, into current button, which we have comments here, getting it from the hardware register, and then copying it into current button. And basically, if it's non-zero, the button is up. If it's 0, it's down. So what we care about on this particular thing is if the button is pushed. The next section we have is that if we get to this, the button is pushed down. And so now what we're going to be doing is we're going to be loading in the whatever's in stick button into the A register. Now, this is what the button was set to before. This is how we're going to be doing the debounce logic. So we say, get the previous button state. So by default, it's going to be set to 0. We may want to set it to 1, but one cycle through read joystick will automatically set it back to whatever it should be. So in this particular case, it's going to be setting it to 1 because we're copying it in and it's set to 1, so we're good. And then now we're checking it and it says, okay, if it's non-zero and the curtain button stays 0, it was just pushed. What we're trying to do is technically called edge detection. If you look at, like if it were on a graph, we have the 0 and then we go up to 1. Well, what we want to do is we want to catch it when the player is going when it's going from 0 to 1. So that's the idea. That's the button push action. That's when we want to actually do something. So we're saying, okay, it was just pushed. Now we have if they've held it down. So we say, okay, the button is held down. Get the action state. So this is previous action. What we've done is we've set up a variable that says this is the last thing we did. And then we're saying, okay, if it's non-zero, don't do the action again. So we are setting a variable to say, hey, we've done something so that we don't try to do it again within this cycle. And we want to basically make sure that it goes back down to 0. It's just a simple flag, 0 and 1. We could actually eventually do it to where it's like, oh, when you open a door, it's a 1. If it's a this, it's a 2. It's et cetera, et cetera. So we could obviously expand upon that, but for right now, we're just going to use 0 and 1. Okay, so we have read the direction pointer. So this is a new procedure that we're going to be adding, and then do the action. So this player action is also another one. Okay, so we have the down state, the held state. So if we're looking at the graph, we get the edge going up, and then we have the one at the top. And we're going to say, once we've done the action, we're going to skip to done, which we're going to be putting here in a second. And so now we're going to say the up is up, meaning it's not pushed. Okay, so the button is currently up, and we're going to say update the direction pointer because we still need to be able to handle movement. We're going to move the player because this time the button is up. That means we're moving. We're not doing an action. And then what we're going to do is we're going to clear the stick action. So the idea is that if it's the player's moving, we're not in the middle of doing actions, okay? So that's where we're clearing the stick action. And then we are done. And then we say, set the stick button for next time. So whatever the state is right now, we want to set it so that when we check it next time, we can see if it's changed or not. So we're just going to copy, current button into stick button. So let's walk through real quick again. So we first set up our temp variable. We get the state of the button, and then we say, okay, if it's non-zero, the button is up. If it's 0, that means the button is down. So in this case, the button is down. So we're going to say, okay, get the previous state. If the previous state is non-zero, so basically we're checking to see if it has changed and if it's going up. So this is a press down event. The held is when it's on the top. It's being held the whole time. So this is actually where we want to be doing the action for the player, is when they have not only just pressed the button, but held the button. So we hold the button and then we push a direction. One of the things I ran into when doing a lot of this code was it would work as long as you pushed the button and pushed the direction at the same time. That was okay, but it was really not a good experience. You want to be able to say, okay, if I'm holding the button, I can't move around at this point. I am doing an action with that button. So that's this state right here. This is the main bread and butter of doing actions. Okay, and so if it's not being held, then we're saying, okay, it's a movement. So that's where we're doing here. Now, in both cases, we have to read the direction. So we don't need to do this in any other state, but this is going to say, are we pushing up? Are we pushing right, left, all that stuff? And it's going to be setting our enumerations that we were talking about. Okay. And let's see, move player. So we talked about this. If it's cleared, if the player is moving, the action is being reset back to 0 because we don't care. We're moving, the action has been cleared. And then when we're done, we get down to the done here and we just set it for next time. All right. That is the new read joystick procedure. And right now, this would break because we have a bunch of procedures we haven't covered yet. So what I'm going to do is I'm going to actually create these read direction, and I'm just going to stub them out. Okay. And I'm going to say RTS and then NP. And I'm going to do the same thing for player move and player action. Okay. These are going to be just for right now. And the reason why I want to do this is I want to get this new read joystick into our code because I want to make sure that the code is working. Now we can't really test it if it's working because we haven't implemented the move. That's what we're going to do next. But let's see if we can get it past the assembler because these won't work if they're not at least in here. Okay, redirection is there. Player move, player action. I believe that's all of those. So we also need to import this input.asm. So let's go ahead and add that. So we've been putting these down here. Where to put them? Good question. I'm going to put it in here. Let's see if it breaks things. Now, I have seen that where you put this does actually matter, mostly because if you're not careful, things can overlap into memory locations and can break. So right now, we've called this read joystick, and the problem is we already have a read joystick. So let's just make sure, because I've had issues, I am just going to do that for now. And then what I want to do is I want to make sure that it still assembles and it still runs and it doesn't have any weirdness. I will say that when I was doing this, something changed when I was doing this, and I want to try to figure it out. Basically, the location of the starting location changed, like the map had changed when I was working on it. So I want to do it step by step to make sure that we're not breaking anything on the way. Okay. So we have multiple declarations. Okay, that's fine. So let's say stick up, stick right. Okay. So apparently I already implemented those. Let's look. Or I put them somewhere else. Stick down is declared twice. Oh, you know what? I bet I put this in the joystick, read joystick in the other function. So let me go look here. Stick up. Here we go. So that's where these all are. So let's just comment these out. Okay, and then that's gonna fix most of these. We still have temp2 declared twice. Okay, temp2. So I use temp2 here, and then there's also a temp2 here. Fine. I don't really care at this point. Again, we're going to be going through and fixing up the memory map, but it's fine. So let's see if things broke. I know that the movement is not going to work because we haven't implemented anything yet. I take that back. Everything should still work. My joystick is apparently the battery is dying. Great. Of course. All right, let's double check. I hadn't turned on my joystick before, so let's verify. Okay. All right, so everything is still the same. We still have collision detection turned off, and but nothing broke, nothing changed with the map. That's what I was afraid of. So the importing of the code didn't break anything. Okay. So let's try to replace this read joystick, the old one, with this new one. So let's find read joystick. And so this is our old one. So a whole lot of stuff in here. Let me just comment this out. And let's see what happens. I know that movement is broken now, but it shouldn't break anything else. Keyword shouldn't. Okay, no movement. We expected that, but we're in the same location. That's important. All right, So let's keep going. Let's say input, we have the read joystick. It is now starting to do it, and we can assume that it is checking down here and saying the button is, if the button's held, it should be doing player action. If the button is not held, it should be doing player move. So let's implement read direction, because we need that first. Okay, so let's do that. Starting it off, we have some comments. Get the direction from the joystick and update the direction pointer. Does not support diagonal movement and is processed in the following priority order: up, down, left, right. So that means when the player is holding down, say, a diagonal, it's going to be going in this order. So if it's up and left, only up is going to be processed, and that's just, that's one of those things when you're dealing with a 4-way movement scheme and an 8-way joystick. It's just the way it is. And in fact, this is an analog joystick that's being mapped to digital, so it's even one step further. So we have redirection, and I'm starting to do the same kind of similar thing with now we're saying stickdir is going to be a temporary variable here, which I might have actually already set in main. Let me see here. Stickdir is, let's see. Aha, yes. I don't think we need this because I'm using stickdir as a temporary variable. Lot of iterations on this. So when I was going through this, so we've said, okay, stickdir equals temp2. Now, the reason why I use temp2 and not temp1, because this procedure is going to be calling this procedure. We don't want the variables to clobber each other. If we use the same temp variable, we're writing to one, reading from it, it's going to be a mess. So that's why we definitely need multiple variables here. So we've got the temp2, stickdir is going to be our temp variable for this procedure. We're going to do some initialization here, and we're going to say the player pointer is going to be copied to the direction pointer. So the player pointer, and we're working on this new kind of paradigm here. In what we did before was we had player X and player Y. Well, those are nice human readable numbers. It's awesome to have a location, and we may want to bring it back. But the problem is when we have that, every time we do something with that, we have to calculate and say, oh, okay, if it's -1, we've got to do all this work every time we do this. When we're dealing with it just as a pointer, that means we can deal with it directly. So we don't have this kind of indirect thing that just causes a lot more cycles to be used, etc. So this will be a lot cleaner, at least for now. So we're going to first copy the player pointer to the direction pointer. This is where the player is at. And so, like, if we don't do anything, direction pointer is going to be exactly the same place as where the player is currently located in the map. And we're going to say, okay, MVA stick 0 to stickdir. So that is the bitmap that we're going to be getting from the joystick. So we're going to say, okay, load the stick bitmap from the hardware register. And now what we're going to do is we're going to compare for each one of these. Say check up. So we did something very similar before, and that's actually, if we look at our old read joystick, it's going to look very similar to this. So this shouldn't be too new. So we're going to end it with stick up, just to say, hey, is it pointing up, or is up in the bitmap? So that's where the and comes in, by saying, okay, up is, I believe, 1. Is that bit fired on here? And if it is, that's all we really care about. Okay, so we're anding stick up with whatever is in the A register, which is going to be stick 0, what is from the joystick, okay? And we're going to say, all right, so if it's 0, that means the joystick isn't moving anywhere, okay? So if it is pushed a certain direction, then we can act on it. So in this case, we say B and E check down. So if it's not pushed up, so at this point, and is going to have zeros and a 1 in a certain bit. All right. So we're going to say check down if we're not pushing up. If it's not pushed up, so move to the next check, okay? Now, if it is being pushed up, that's where we get into this section here, and we're gonna say, we're gonna put direction pointer at one row above the player pointer at this point, because we're pointing up. Now, we may be moving up, we may be like doing an action up, and this procedure handles both of those, and that's why we needed to do a little bit of restructuring here. So it is pushed up, so move the temp pointer up one line. Okay, and so this map width is obviously the width of the map, and so the way it's laid out in memory, if we go up one row or one line, you just have to subtract what we're currently on. So that's what this SBW, which is subtract word, that is a MADS macro that allows you to do it so that you can just handle in words as opposed to just bytes. And it also does things like clearing the the flags that you need to clear when doing adding and subtracting, etc. And once we've done that, we can get out of this function. We don't care at this point. So we're going to have, next one we're going to have is check down. So very similar, but the one difference here is that we do an LDA of stickter. So anytime you do an AND, it overwrites what is in the A register. And so we need to recopy this. Now, we could have an LDA stickter here, but there's no real point. It's just an extra cycle. It's always going to be the correct value there. But in this case, we've modified it, so we need to recopy it. So that's why I say recopy non-mutated stickter to A. Then we're going to AND it with down, check to see if they're pressing down. And then if not, we go to the next check. And then in this case, we are pressing down. So instead of subtracting the map width, we're going to be adding the map width, which is going to push it down one level, one line, one row, whatever you want to call it. So next check is we have this one here. We're going to say check left, same exact thing here, and stick left, see if it's pushed left. And if not, we go to the check right, which is the next check. And then in this case, instead of subtracting the map width, what we're doing is we're actually subtracting just the 1 byte from this. So that's why we have the decrement here. Now, one of the things I'm missing here is RTS. I forgot it when I was doing my code. It's not that big a deal. It's one of those things that it's just an early exit, makes it more efficient. Now we're going to do check right. Very, very similar. So it's almost identical except for the right, left stuff. But we are going to be doing, we've gone through these checks. Now we're going to say done. Okay, so real quick though, instead of going left 1 character, 1 byte, whatever, we're going right 1 byte. So we're going to be adding 1 to it. And then we'll put this at the end. We're going to say done. Okay. So at this point, we have dir pointer should have the direction in which the player is pushing the joystick. It's going to be an enum with 0 being no direction, 1, 2, 3, or 4 being north, south, west, east. And so let's double check to make sure that this isn't broken. Okay. Again, shouldn't change anything. We can't move yet, but it should still assemble. It shouldn't break the code. So let's see what happens. Okay, looks good. My map didn't blow up, etc. So next, we've got redirection. Awesome. Let's actually put the movement back. We've got player move. Okay, this one's a lot smaller, so I just copied and pasted the whole thing. But I didn't put any comments in here, so let's go ahead and add some comments. So this is the macro that we created called LDI. Little simple little macro that just does, loads 0 into the Y register, and then basically it just dereferences whatever's here at this address. It says, give me the tile that is at this address, and with no offset. That's the key thing here. A lot of times when you're using the indirect addressing mode with the Y register, because that's the only one you can use for indirect addressing, you typically are using an offset. We're not using an offset here. We're using an offset of 0 for this particular action. So that's why I set up this macro saying, so we're going to do this. So I'm going to say dereference the direction pointer. So we're getting the tile in which we are pointing at. And so what we're going to do is we're going to say we have BQ blocked. So the idea here is if the direction pointer, the tile that you're standing on is 0, we want to not be moving, okay? We don't want to do anything. We don't need to check anything when we're not moving. So that's where we have this BQ blocked. Okay, so we're going to say not moving. So I'm going to say dir pointer equals 0. Okay, so check passable. We are moving. So now what we want to do is check to see where we're looking is able to be walked on. So this is where the collision detection is. So we're going to have a function called isPassable, which we haven't written yet. Check to see. Actually, I'm just going to do a collision check. Collision detection. Detect collision. How about that? Detect collision. All right. And if it returns, we are setting with the isPassable, which we haven't done yet, we are setting the carry flag. If the carry is set, we do one action. If the carry is not set, we do a different action. So we're going to say if the carry is cleared, if the carry flag is 0, so flag is 0. So we're, so collision, let's see, colliding. How about that? We'll do colliding. And then we're going to say at this point, because we aren't colliding, we can do this. So we're going to say move the player to the direction pointer. Okay. So let's see, can I word that a little bit better? So we're basically updating the player pointer to be the same thing as the direction pointer. So in this case, we are moving on to whatever square we want. So move the player to the correct location. That might be a little bit better. And we can say, okay, we are blocked. It's, we're kind of, it's kind of self-explanatory. But the idea here is we do this check. And if either of these are true, we go down to the blocked and we don't move. Okay, so that's all the player movement is. So now we have the redirection and we have player move. Now, we don't have isPassable. So we need to put that in there. But what I'm going to do is I'm going to stub that out as well. So we're going to say proc isPassable, and we're just going to do RTS NP. Okay. Now, the deal is that we're not setting the clear flag or anything, we're not setting the carry flag or anything here. So it's going to be dependent on whatever the carry flag is set to. But for now, let's just make sure it assembles and nothing blows up. We're not going to be able to move just yet. I'm pretty sure that this is going to block us by this set. Yep, can't move yet. Understandable. We need to implement the isPassable function. So I'm going to go ahead and copy and paste into here. And we're going to say, okay, check to see if the tile is passable. And so we have this noClip variable that we set up last time. So let's see what we got here. NoClip is set to 1. So the way we did the logic was basically if it's at 1, that means you can just walk through any walls. If it's set to 0, that means you can't. It'll normal collision detection will work. So I'm just going to turn that back to 0. That should be the default. But when we're testing, it can be very handy to have the collision detection turned off. So what we're going to do is we're going to say check to see if no clip is turned on. Okay, and we're going to go down and we're going to say if it is basically if the collision detection is turned off. So actually I'm going to say check to see if collision detection is active. That might be a better way to say it. And if not, skip to passable. So collision detection is turned off. That means we're always able to move. Okay. So at this point, collision detection is turned on. And so now what we're going to do is we're going to do this, the dereferencing whatever's in the dir pointer, which is exactly the same thing we did over here. So I'll just go ahead and copy and paste that because I'm lazy. Okay. All right. So now what we're going to do is I renamed the walkable start, which we have here. I changed this to passable min. It fit more of, I think, what I was trying to accomplish there. Walkable versus passable. I'm just going to change this the naming to passable. So we're comparing the A register to passable min. So we're going to say, is the tile passable? Okay, so at this point, to get tile. So we're going to say, wherever we're pointing, get the tile and say, is this tile passable? And then if so, we do one thing, but if not, we do another. So we're going to say, if it is blocked, as in if it is passable or not passable. So we're going to say not passable. That means it's going to go down to here. So the idea here is we're branching carry clear. Branching on carry clear, I should say. So this compare sets the carry flag. And so if it's 0 or 1, we do different things. So if it's setting to 0, which carry clear means that we're going to say that the carry flag is 0. That means this tile is not passable. So we're going to skip down to blocked. So now here, we're saying if we get into here, that means that the tile is passable. So we're going to say, we're going to set the carry flag. And we're going to say tile is passable. So set the carry flag. Okay. And then we're done. And then we go down to here and say tile is blocked or not passable, either one. So clear the carry flag. So if you remember, in our previous procedure, the player moved, we're checking to see what the return is with this. So this is going to be the carry flag. So dealing with this, so we're saying carry flag equals this, we do this, carry flag this, we do that. So carry flag equals 0, so we're colliding. Carry flag of 1 means we're passing. And this would be a good way to do this. I'm going to say carry flag equals 0. Let's see, I might put in actual words here. If carry flag is 0, we're going to say collision if carry flag is 1, passing. No collision, I guess. All right. So now I think the movement should work. Crossing fingers. Negative. I think I know why. That has to do with our update function in the main routine. So I think we are pushing the player pointer around. We just can't see it. So we'll deal with that next. All right, so let's see if we can make this work. So let's go back into main. And yeah, the player pointer is really what the crux of everything is now. And we're not doing anything with it. So we're moving everything around, but yeah, can't see the reaction from that. Yeah, whatever. Okay, so the bulk of this here is this map offset function. So this gets called every frame. Okay, so we let's see what we're calling it here. Map offset. That happens in Blitzscreen. And so what's happening, and this is kind of what I was talking about earlier, was the fact that the X and Y stuff has to be updated every frame. And that's not very efficient. So I actually have a new function for this that's a lot simpler. All right, I am going to just comment this out again, just in case. And I'm going to paste in my new map offset. Okay, so that is a lot simpler. So what we're doing with the map offset here is, the big thing here is that we need to make sure that the screen lines up with where you are on the map. You know, if we're in, you know, we have to do an offset thing, and that's where this player height divided by 2 times the math width is, so that we say, okay, we go over by a certain amount, and then we go down by a certain amount. So here what we're going to do is, I'll go ahead and put a comment here. So we're going to say, wrong language. We're going to say copy the player pointer to the map pointer. And actually, yeah, so we're going to say player to, let's see, player location to map location. Using the same words doesn't make any sense. It doesn't gain any value. But what we're going to do is we're going to say subtract, that's a new one. Subtract so playfield height is going to be, you know, height. Well, I could say, yeah, height times there divided by 2 times the map width. What this is we're going to say, you know, if we look at actually here, this is the same code that we did before, this playfield height divided by 2. And so we're able to actually condense this quite a bit. And so we're subtracting from that. We know these sizes here. So we're going to say subtract really the height and subtract the width. And I could go into the whole the formula for that, but you can pretty much see what it's doing. And we're doing a map offset every frame still, but that's okay. Or actually every tick. I wouldn't say every frame. But we're doing this, and then this update player tiles, I don't think is used anymore. So let's say if we look update player tiles. Update player tiles. Yeah, it's not used. We don't need all of this code here because we're not using it. So I can comment this out, find anywhere else we're calling it. So this is a huge, huge amount of improvement here as far as cycles, code space, etc. But let's see if it works. It's probably going to blow up on me, knowing my luck. Boom. Yeah, I ran into this too. It crashed. So let's break this down. And it's quite possible I have a bug, but I did get this working before. So let's see what happened. Okay, so we have map offset. And we're copying player pointer into map pointer. There's probably some initialization that I didn't do. Player pointer is not set, and we need to set that. So let me look at player pointer. I think I did some init work that I didn't copy. Maybe. Init player pointer, there's a procedure called that. So let me go ahead and put that in there. Yeah, we don't need to do that. Okay, so we're going to put in, here's fine. We're using it. So we're going to say init player pointer. So we only need to do this on startup. We're saying, or actually it's going to need to be done anytime we change the map. And so we're going to say copy the map to the map address to the player pointer, because this is going to start it out. Okay. And then we have to say, so we are still using the player Y and player X. Now this is only going to be used at the very beginning. And eventually we might be able to, refactor this out, but for now, we're still using it. So at the very beginning of the program, we're initializing player Y and player X to be, I believe it was 16. Let me see. Player Y, player X. Yes, we are we're copying in X and Y of 16. Now on this init player pointer, let's see, init player pointer, we're going to copy this here. And what we're going to do is we're going to be doing the same logic that we did before, but the difference is we're not doing this all the time. It's going to be just at the beginning. So we have the load player Y. So we're going to keep that in here right now. We're going to say load in Y locations, Y starting location. Okay. And then we're going to go through and we're going to loop this here. And we're going to say add the number of rows. Or actually, I guess I'll just add a row. And we're doing this decrement for the number of rows that we have. So I'm going to say number of rows. And now what we're going to do is we're going to say decrement Y. Again, comments that don't tell you anything is kind of dumb. I'm just not going to comment that. How about that? We're not done. I'm going to say keep going. Okay. And when we're done here, now we are adding in the X location. So we've added the Y location. And I think I'm going to do this just to give it a little bit of separation here. And I'm also going to do this. I'm going to say, we could do a comment, or we could put in a label, but I'm going to say move number of rows, shift. I like shift better. Shift player Y rows, shift player X columns. Okay. So this is, so if you remember, ADBW is adding a byte to a word. And so there's ADW, which adds 2 words. And this will work fine because this is a static value. It's not a value that's in a memory location here. The problem is if you normally would just do this add, if it goes across a boundary, you're going to have problems. So that's why I created this macro, this ADW BW. This is one I created a long time ago, but just for a just for a refresher, we have ADBW. It loads in the source and the destination goes through. And then basically it will only handle copying the byte value and not try to copy the word. Because one of the problems that I ran into was if you have a byte, or if you have a byte that you want to copy to a word and you use ADW, it's going to assume that it's going to be copying 2 bytes. Well, what's in that next byte after the one? That's where this +1 comes in. What's that next byte? The problem is we don't know because we're not expected to be dealing with that. That's a byte. It's not a word. And so the problem is with the ADW, it's assuming a word, and that's bad news with what we're trying to do with this particular thing, because player X is a byte. Now, we could make it a word. That might make things a little easier, but why use more space? There's no problem. When it's only going to be, we've already established that we can only have a width or a height of 255 tiles. I think that's plenty for a map size. If we want to go bigger, then we would need to cross into word territory. We'll deal with that if we need to. So we're going to say add the player X number of columns. This one's easy because you don't have to worry about it going across a byte boundary. We have to deal with this stuff because when you're adding 56 bytes at a time maximum, then you're going to run into the overflowing variables left and right. So that's why we have to do this in a loop. It's a little bit more of a pain versus just adding. You can't just do BW player pointer player Y and add player X because it just won't work. You can't do it that way. So you have to do it in code. All right. So we've done init player pointer and we haven't called it yet. So let's go ahead and call it up here and see if it's any better. I'm hoping. Okay, so we're going to do it before our main game loop. So init player pointer. Okay, let's see if this is any better. Okay, it isn't. All right. So we could go into debugging it. I'm trying to think of what the problem could be other than that. And I think I'm going to take this offline in order to figure that out. I don't think we want to do it on the video. So I will be right back with the solution. Don't go anywhere.
One eternity later.
Okay, so as you can tell, I'm wearing a different shirt. It has been a few days since I last recorded this video, and it took me a lot longer than I was hoping to be able to fix this bug, but I did fix it. And it's very simple, actually, and of course, that's the way it always is. I forgot to add the screen pointer, adding the screen to it, and that broke everything. So theoretically, if I put that back in, and if I run it, theoretically, it won't crash. Crossing my fingers, and we'll see. There we go. Okay, we have movement. We have collision detection. Now we can move on. That was very frustrating, but I learned quite a bit of stuff. So let's continue on, shall we? Okay. So where we were last time was that we implemented the player move, and we still have player action to implement here. So we just have a simple stub here. Okay, so we're going to have the ability to open and close doors. So that's where we get into this player action section. All right, so what we're going to first do is we're going to figure out what tile is at dir pointer. Okay. So we have our little macro in here. We should called LDI. LDI right here for loading by. Let's see. It's basically dereferencing a pointer. We're just saying load it in, but doing it with indirect with a 0 in it. So let's just do that. So we're doing LDI dir pointer. What that's going to do is that's going to load into the A register whatever tile is wherever the direction is going. So let's just go ahead and put a comment here. Load in tile from direction. I guess that's an okay way to do it. And now what we're going to do is we're going to check to see what tile it is. And we only want to do actions based on certain tiles. And for this video, what we're going to do is we're going to see if it's a door or a doorway. If it's a door, we're going to be able to convert it to a doorway. If it's a doorway, we convert it to a door. Pretty simple. This thing will be a lot bigger once we get into more actions, picking up chests and fighting monsters and stuff like that. But this is going to be the skeleton. So we're going to do check door. I'll put a space there. It looks better. And we're going to compare with map door. Now, if we look at the labels, we've got these map ones set up here. We have map door and map doorway. And I'm not 100% sure that is correct. We'll look at that in a second. But we need to go back. So we're going to compare it with a door. Check if it's a door. And if not, we're going to just go to the next check. This should seem pretty familiar. This whole, we check this, and if not, we keep going down the checklist. And that's what I found to be a pretty decent way to deal with this. So we're going to say, nope, not a door. Skip to next check. Okay, and now, if we get here, we're going to do open door. Open the door. So we're going to be creating that function in a minute, but then we're going to just RTS. We're done. So now we're going to do check doorway, and it's going to be very similar. Doorway. I'm just going to copy this, and we're going to say compare to see if it's a doorway. Check if it's a doorway. Nope. I'm just going to make this generic again because it's pretty self-explanatory, I think. And we're going to have I'm going to create the next one. I'm going to call it none. Not num monsters. Stop helping. Okay. I'm going to do that. And we're going to say open. Let's see. We're going to do close door. Close the door. And so now we're going to do none, and just a simple RTS. Nothing to do. Okay. So that is our player action procedure. Now, since that won't really do anything and it won't assemble because we don't have these defined, let's go ahead and define those. Okay. So I'm going to go ahead and type it. Why not? It's not too bad here. Let's see. So I'm going to say .proc open door. And we're going to load in map doorway, which is the tile we want to convert to. Load in the doorway tile. And then we're going to do an STI dir pointer. Okay, so we're going to be swapping door with doorway. So we've loaded in the doorway tile, and now what we're going to do is we're going to swap door for doorway. So opening the door. And now what we're going to do is we're going to increment the stick action. So we have the stick action in here is the action state. What we want to be able to do is we want to be able to set it up so it's debounced. So we don't want to have the user being able to hold down the button and opening and closing and opening and closing. So what we do is we set a flag that says, hey, we did something. Don't do it again until that flag gets cleared. So that's what this increment stick action is. Set the action flag. And then RTS. And, oops. And we're going to do an NP. And then we're going to do the same thing for closed door. Uh-oh. We're going to say closed door. We're going to say map door instead of doorway. And we're going to load in the door tile. Swap the doorway for door. And set the action flag. That should be it. One of the things I want to check here is I want to check to see if our labels are correct, because I remember there was an issue. Yep, as I was afraid. Okay, so I had set door to 4 and doorway to 122. Now, that 122 was suspect, so that's actually the character number and not the tile number. If we look at, say, the original graphic, let's go ahead and pull that up. So the idea here is that, you know, starting from the upper left, we have 0, the tile 0, tile 1, and all the way to tile 7. Then we go down, we go 0, 8, 16, etc. And eventually we get to a point where we're going to get up to 63. So the bottom right is supposed to be 63. If we count backwards, we're going to get to 59. So that's where that is set. So it was originally set to 122. Again, that was if you were going to be calculating based on the character number, but this is tile number here. Okay, let's try it and see if it explodes. See what happens. Okay, so we're able to move around still. That didn't break. Collision detection still works. Now, the idea here is I should be able to hit the button and put it in a direction, and it won't do anything if I'm not putting it at a door or a doorway. So I'm going to hold down the button and see what happens. Okay, good. I am moving it in the directions, and I'm holding down the button. And if I let off, we're good. That's the correct thing. Now let's see if it opens the door. Nope. It changed it into a chest. Okay. That's not what we wanted to do. All right. So we got to figure out what the right number is. The graphic is incorrect, but the what it's doing is correct. That's funny. It converted it into a treasure chest. So let's figure that out. It's quite possible that my graphic, I changed it or something. So let's take a look. But the functionality is working. It's just picking the wrong tile. So let's take a look here. Let's go back to that image here. So if we have 63 as being the bottom right, I don't know if you can see my mouse pointer, but 63 being there, 62, 61, 60, 59 is the doorway. Okay. And it's off by 1, it looks like. So that's interesting. So let me look at, say, what I am doing in my other code. And it's possible that I need to rerun our graphics thing, but let's figure it out here. Okay, so looking at the other graphic that I had before, it's in the correct spot. So that shouldn't be a problem. And just to double check, it is map doorway, and in the labels, it is not changed. I didn't change it. I thought I changed it. It's supposed to be 59. Let's try again. So that actually should explain the problems, because it was set up to swap the colors. So let's see if it works now. Yep. All right. There we go. So we have a working door. So like, let's say monsters are coming after you can close the door on them. You can open the door, you can close it. So yeah, we have a big obstacle course going on right now with the monsters, but that's okay. Let's see if we can actually get through. I don't think we can. I think we have a monster stopping our way, but let's see if we can get through. Why not? It's fun, right? Okay. Where is it? It's up here. Okay. Boom. Boom. Yep. So yeah, we have monsters in our way to be able to get to the exit. So I'm pretty sure the exit is wherever. Is over past this door, but we can't get to it yet. So that will be a topic for another episode. So we actually got what we wanted to do. We now have a definitely more streamlined way of dealing with the movement and the actions, as well as the direction pointers and the player pointer and stuff like that. Instead of dealing with the XY, which XY is great, the problem is that every time you update it, you have to do all this calculation, and it's just not efficient. We wanted to do something different there, and I think this is a much better way to go, and it'll be able to scale a lot better when we go forward. Thanks for watching the video. I hope you liked it. If you did, be sure to hit that like button, and if you'd like to see more of my content, hit the subscribe button, ring the bell, all that goodness. I try to post content when I can, but I know it's been a little while since the last one, and can't make any major promises, but I do have quite a bit of stuff coming up soon. So until then, see you in the next adventure. Take care.